Right, lastly, beating. What happens when omega, so there's our solution, what happens when omega approaches omega naught? You have this term, sine omega d omega t, and sine omega naught t, they're almost going to be the same, okay? There's both sinusoids, but slightly different frequencies. And what happens is you have phase drift occurring, okay? Sometimes these frequencies are so close that those two terms will add together or subtract from one another. Obviously, if this is opposite to this, then that essentially becomes a plus. They add together to reinforce, okay? But sometimes, obviously, they will be in sync with each other. You have a minus sign, they'll cancel each other out. And because these two are close together, that term is essentially 1. Yeah? So you have, sometimes it will be sine omega t minus sine omega naught t. Those omegas are close together. At some points, that's going to be 0. Obviously, as you increase, as time continues, they'll end up being out of sync. Okay, so you end up with basically sine omega t plus sine omega t. They will reinforce, and you get this thing called beating. Okay, to work out what the period is, you take the difference between the two frequencies. Okay, obviously I was working in hertz, so it's 2 pi times that difference. 2 pi times by the frequency of beating, and obviously to get the period, you take 1 over that difference in hertz, and you end up getting the beat period. So that's beating. And that's what it looks like if we was to plot it. So that's taking the equation that we had before, this one up here. Okay? And then if we plot that with respect to time, I end up with this being my case. Okay? So we end up from 0. Obviously it increases to a certain maximum where they add each other together. You get 2 times it. Then obviously they will cancel each other out, where you get the 0, and obviously they increase and so on. And there's our beat period. Okay, the beat period being not the frequency of the oscillation, but the frequency of the beating that's going on.